We are TENA Orbit Guardians, an in-space collecting, recycling, and manufacturing company. Our group of three came together because we were passionate about space, a new frontier currently being explored by top scientists and engineers throughout the world. But we all knew that in our night sky was a huge problem. What kind of problem? Well, it orbits thousands of kilometers above Earth's surface. It's one of humanity's most pressing problems in space debris. But our company came together because we were confident that we could solve this issue. What if we could use this space junk? Well, with TENA, this problem of the past is now the catalyst for a new future in space.
Our system deploys AI-equipped drones to low Earth orbit. These drones are engineered to automatically detect, identify, and prioritize debris based on its dimensions and compositions. Using robotic arms and nets, they efficiently collect fragments as small as 10 centimeters and large objects weighing up to 50 kilograms. Once the debris is collected, the drones transport it to an orbital recycling station. At the station, the debris is sorted and processed into reusable materials like metals, polymers, and electronics. When the drone's expandable storage containers are filled or their fuel supply is running low, they dock at the station to unload the collected debris and refuel. During the unloading process, AI-driven sorting system analyzes the materials and prioritizes valuable resources such as aluminum, titanium, and gold. These high-value materials are stored separately from non-recyclables. After sorting, the materials are processed in a way that can be used for manufacturing. These processed materials will then be used to produce tools, components, and other essential objects through modular 3D printing. Finally, the drones will take the manufactured parts to the specific location the consumer asked for and continue its mission from there.
Our core technology is a sustainable collection system. The drones will have two main components, thruster and collection system. The drones use Hall effect thrusters as the main propulsion and cold gas thrusters for direction control. The propellant for the Hall thruster is krypton, which is imported from the Earth. The Hall thrusters use Hall effect and magnetic field to accelerate ions, in our case kryptons. While xenon is more often used in space exploration, it is 10 times more expensive than krypton. Furthermore, for our use case, small space drones, we do not need the propulsion powers that xenon can produce, so krypton is more suitable for our innovation. The propellants will be transported to the mothership regularly as a gas, and drones recharge propellants and electricity as they return collected debris to the mothership. Talking about collecting debris, as there are various sizes and types of debris in space, we have two catching methods. For relatively small debris, we are using an electromagnetic plate to catch and release debris easily. For larger debris or satellites, however, we are using robotic arms or tentacles to hold them securely.
Even though humanity has made large strides ever since putting the first man in space in 1961, we still have a long way to go before making self-sufficiency in space possible. Even the ISS still needs to depend on Earth. But what we do know is that there's merit in TENA's space debris collecting drones that will become part of a new driving force to improve future space endeavors. Cleaning up space debris with our fleet of versatile drones will exemplify the means for which future large-scale space operations will follow our example of ensuring that pollution will not run rampant in space as it has on Earth. And as we've conveyed, in-space manufacturing promotes growth for our partners, whether they be businesses or government space agencies. As a significant step towards a sustainable future in space, TENA will serve as a success that future space exploration efforts will build upon. So join us at TENA to pave the way forward for a better future in space exploration, one drone at a time.